Now moving on to the ninth question. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ, and show that first thing, triangle APD is congruent to triangle CQB, and second, AP is equal to CQ. Third, triangle AQB is congruent to triangle CPD, and AQ is equal to CP, and lastly he asked us to prove that APCQ is a parallelogram. Now moving on to solution. Let us note down the given information, that is ABCD is a parallelogram. Let us note down the properties of the parallelogram, that is AB will be parallel to CD, and also AB will be equal to CD, and AD will be parallel to BC, and AD will be also equal to BC. Now he asked us to prove first thing, triangle APD is congruent to triangle CQB. Second thing, AP is equal to CQ. Third thing, triangle AQB is congruent to triangle CPD. Fourth, AQ is equal to CP, and last, APCQ is a parallelogram. In the first thing, he has asked us to prove that triangle APD is congruent to triangle CQB. So let us consider both triangles, that is triangle APD and triangle CQB. In this, AD is equal to BC. As we know that ABCD is a parallelogram, opposite sides will be parallel and equal. And next thing, let us consider that AD is parallel to BC and BD as diagonal. Then we get angle ADP is equal to angle QBC, as AD is parallel to BC and BD is diagonal or transversal. We can say the alternate interior angles above the transversal will be equal. So we can say angle ADP is equal to angle QBC, as they are alternate interior angles. Now he has already given that BQ is equal to DP. Now here, if we observe, in both the triangles, the two corresponding sides and included angle between them is equal. So we can say by SAS property, both the triangles are congruent, that is triangle APD is congruent to triangle CQB. We know that when two triangles are congruent, then the corresponding sides and corresponding angles can be equated. So here the corresponding sides AP can be equated to QC. This is what our second subpart of proof required. Now in the third bit, he asked us to prove that triangle AQB is congruent to triangle CPD and AQ is equal to CP in the fourth bit. So in order to prove this, let us consider both triangles, that is triangle AQB and triangle CPD. In this, AB is equal to CD. Since ABCD is a parallelogram, the opposite sides will be parallel and equal. And he has given that BQ is equal to PD, however. Now, if we consider that AB is parallel to CD and BD as diagonal, then angle ABQ will be equal to angle PDC, since they are alternate interior angles. Now, the two corresponding sides and the corresponding angle of both the triangles are equal. Therefore, by SAS property, we can say triangle AQB is congruent to triangle CPD. When two triangles are congruent, we can say the corresponding angles and corresponding sides can be equated. So here CP will be equal to AQ. This is for the fourth subpart of proof required for us. Here also we can equate the two corresponding angles, that is angle AQB is equal to angle CPD. Now, if we consider line BQD, here angle AQB and angle AQP form a linear pair. So we know that sum of angles on a linear pair is equal to 180 degrees. We can say angle AQB plus angle AQP is equal to 180 degrees, and also angle here, if we consider line QPD, also angle QPC and angle CPD form a linear pair. So sum of angles on a linear pair is equal to 180 degrees. As this both angles are equal to 180 degrees, we can equate angle AQB plus angle AQP is equal to angle QPC plus angle CPD. From the above, we can say that angle AQB is equal to angle CPD, so that can be cancelled on both sides. Then we get angle AQP is equal to angle QPC. Since angle AQP is equal to angle QPC, we can say the two angles on either side of transversal QP is equal. That means here the alternate interior angles are equal if AQ is parallel to PC, and also we know that AQ is equal to PC. Now similarly, if we consider the first proof that triangle APD is congruent to triangle CQB, we can prove angle PQC is equal to angle APQ. So here also the two alternate interior angles about transversal QP will be equal. So we can say QC is parallel to AP, and also initially we got that QC is equal to AP. So here if we consider in the figure APQC, AQ is parallel to PC and AQ is equal to PC, and also QC is parallel to AP and QC is equal to AP. Here in this figure, the opposite sides are parallel and equal. So we can say APQC is a parallelogram. This is what our fifth proof required. Now moving on to a 10th question. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C. On diagonal BD, show that triangle APB is congruent to triangle QCD. Show that triangle APB is congruent to triangle CQD. And second thing, AP is equal to CQ. Now moving on to a solution. Let us note down the given information that ABCD is a parallelogram with BD as diagonal, and we are required to prove that triangle APB is congruent to triangle CQD, and second thing, AP is equal to CQ. Now moving on to the proof. Let us consider both the triangles, triangle APB and triangle CQD. So here they are, APB and CQD. In this, angle APB is equal to angle CQD is equal to 90 degrees. Since he has given that AP is perpendicular to BD and CQ is also perpendicular to BD. Now AB is equal to CD. As in the parallelogram, opposite sides are parallel and are equal. Now if we consider AB, that AB is parallel to CD and BD as transversal, we can say angle CDQ is equal to angle ABP, since they are alternate interior angles. So here in two triangles, the two corresponding angles and a side is equal. So we can say by ASA property of congruence, triangle APB is congruent to triangle CQD. Now this is what our first proof required, and now by applying the concept that the corresponding sides and corresponding angles of two congruent triangles are equal, here we can equate the two corresponding sides, that is AP is equal to CQ, which is what our second proof required. Moving on to 11th question. In triangle ABC and triangle DEF, AB is equal to DE and AB parallel to DE. BC is equal to EF and BC is also parallel to EF. Vertices AB and C are joined to vertices DE and F respectively. Show that quadrilateral ABED is a parallelogram, quadrilateral BEFC is a parallelogram, AD parallel to CF and AD is equal to CF. Quadrilateral ACFD is also a parallelogram, AC is equal to DF, and sixth, triangle ABC is congruent to triangle DEF. Now in order to prove this, let us move on to the solution. He has given that AB is equal to DE as well as AB is parallel to DE and BC is parallel to EF, and he also given that BC is equal to EF. Now he asked us to prove that first thing, ABED is a parallelogram. Second thing, BEFC is also a parallelogram. Third thing, AD is parallel to CF and AD is equal to CF. Fourth, ACFD is also a parallelogram. Fifth, AC is equal to DF. And sixth, triangle ABC is congruent to triangle DEF. In the first thing, he asked us to prove that quadrilateral ABED is a parallelogram. In order to prove this, let us consider the quadrilateral ABED. In this, he has given that AB is parallel to ED and also AB is equal to ED. Since the opposite sides are parallel and or equal, we can say the given quadrilateral ABED is a parallelogram. In the second thing, he asked us to prove that quadrilateral BEFC is a parallelogram. Here he has given that BC is parallel to EF and also BC is equal to EF. So as the opposite sides are parallel and equal in a quadrilateral, we can say BEFC is also a parallelogram. Now, initially we proved that ABED is a parallelogram. So we can say from that AD is also parallel to BE and AD will be equal to BE. Similarly, from the second proof, that is BEFC is a parallelogram, we can say CF is parallel to BE and CF is equal to BE. So from these two, we can say AD is parallel to CF and AD is equal to CF. Here in the fourth one, quadrilateral ACFD is also a parallelogram we need to prove. So in the above, we got that AD is equal to CF and AD is parallel to CF. So we can say if in a quadrilateral the opposite sides are equal and parallel, ACFD is a parallelogram. Now as ACFD is a parallelogram, we can say AC is equal to DF and also AC is parallel to DF from figure. Now from this we can say that AC is equal to DF and this is what our fifth proof required. Now finally in the sixth part, he asked us to prove that triangle ABC is congruent to triangle DEF. He has given that AB is equal to DE in the first case and BC is equal to EF here also given in the second case, and finally we got that AC is equal to DF from the fifth proof. So here as three sides correspondingly in both the triangles ABC and DEF are equal, we can say triangle ABC is congruent to triangle DEF. This is what our proof required. Moving on to the 12th question. ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Show that angle A is equal to angle B, angle C is equal to angle D, triangle ABC is congruent to triangle BAD and diagonal AC is equal to BD. Now moving on to the solution. Let us note down the given information that ABCD is a trapezium in which AB is parallel to CD and AD is equal to BC. Now he asked us to prove that first thing, angle A is equal to angle B. Second thing, angle C is equal to angle D. Third thing, triangle ABC is congruent to triangle BAD. And fourth, diagonal AC is equal to BD. Now, in order to prove this, let us extend AB such that CE intersects AB at E and thereby AECD forms a parallelogram. Now, as AECD is a parallelogram, we can say AD is parallel to EC and also AD is equal to EC. But we know that AD is equal to BC, which implies BC will be equal to EC now. Now, if we consider in triangle CBE, two sides are equal, so the angles opposite to that sides will be also equal. So we can equate angle CBE is equal to angle CEB. But here angle B and angle CBE form a linear pair. We know that sum of angles on a linear pair is equal to 180 degrees. We can say angle CBE plus angle B is equal to 180 degrees. Now, if we consider that AD is parallel to EC and AE as transversal, then angle A and angle CEB lie on the same side of the transversal. We know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can say angle A plus angle CEB is equal to 180 degrees. Now, as these two are equal to 180 degrees, we can equate them. That is, angle CBE plus angle B is equal to angle A plus angle CEB. But we know that angle CBE is equal to angle CEB, which implies angle A is equal to angle B. This is for the first part of our proof required. Now, if we consider that AB is parallel to CD and AD, BC as transversals, then angle A and angle D lie on the same side of transversal. So we know that sum of angles lying on the same side of transversal is equal to 180 degrees. We can say angle A plus angle D is equal to 180 degrees and angle B plus angle C is equal to 180 degrees. As both angles are equal to 180 degrees, we can equate angle A plus angle D is equal to angle B plus angle C. Initially we proved that angle A is equal to angle B, so that will be cancelled on both sides. Then we are left out with angle C is equal to angle D. This is what our second proof required. In the third proof, he asked us to prove that triangle ABC is congruent to triangle BAD. In order to prove this, let us join AC diagonal and BD diagonal. Now, as he asked us to prove the congruency of two triangles, let us consider both the triangles, that is triangle ABC and triangle BAD. In these two triangles, AD is equal to BC, since he has given that ABCD is a trapezium in which AD is equal to BC, and we can say AB is equal to AB, which is common side for both the triangles, and also angle ABC is equal to angle DAB, since we got that angle A is equal to angle B for the trapezium. Therefore, by SAS property, as two sides and corresponding angles in both the triangles are equal, we can say triangle ABC is congruent to triangle BAD. We know that when two triangles are congruent, then their corresponding sides can be equated. So here we can equate their corresponding sides, that is AC is equal to BD. This is what our fourth proof required.